Hello, and welcome to a tutorial on using the LexHub Language Coordinator tool. The Language Coordinator facilitates exploratory analysis of language in psychological space by displaying language features, such as words or lexica, as data points along 4 adjustable dimensions: the horizontal axis, the vertical axis, size, and color. These dimensions can be populated by a wide variety of variables, including age, gender, and personality traits, and coordinates along these dimensions represent the degree of correlation with the language features. Manipulating these dimensions can allow for streamlined identification of language patterns across variables, such as viewing the trends and relations of neuroticism, agreeableness, age, and gender all at once. In this tutorial, we will walk through the process of using the tool from start to finish. First, though, let's take a quick peek at a sample plot from the tool to get a sense of what the output will look like. To access the tool from LexHub's homepage, first click on Tools, and then on Language Coordinator. Let's look at the sample output with words selected as the language feature. In this example, conscientiousness and openness are each represented across 2 dimensions. Conscientiousness is plotted along the y-axis and across size, such that the larger a word is, the more highly correlated it is with conscientiousness, and the smaller a word is, the less correlated with conscientiousness it is. Openness is plotted along the x-axis and across color, such that orange words indicate a higher correlation with openness, and blue words indicate a negative correlation with openness. As you can see, there are 4 quadrants. The top right quadrant displays the words that are positively correlated with both openness and with conscientiousness. The bottom left quadrant displays words that are negatively correlated with both openness and conscientiousness. The top left quadrant displays words that are negatively correlated with openness and positively correlated with conscientiousness. And finally, the bottom right corner displays words that are positively correlated with openness and negatively correlated with conscientiousness. For example, the word wonderful is positively correlated with conscientiousness and is not really correlated with openness one way or the other. In contrast, the word universe is positively correlated with openness and is very slightly negatively correlated with conscientiousness. The word the is an example of a word that is positively correlated with both openness and conscientiousness. If we wanted to, we could easily change the traits that are assigned to each dimension. We can do this by hovering over one of the dimensions in the gray boxes at the top of the screen and selecting an option from the drop-down menu. The options that appear in this drop-down menu will depend on the dimensions we include in the file we upload. Let's see how the plot evolves when we change the dimensions. First, I'll set age as the x-axis. Next, I'll try setting extroversion as the y-axis. Adjusting these dimensions allows us to explore language from different angles. Now, let's walk through an example where we upload our own text to see how this really works in practice. There are 3 steps to using this tool. First, we upload our score file. Second, we select the language feature we'll be plotting. And third, we confirm the correlation headers contained in our score file. Regardless of whether we're plotting words or lexica, we will follow these same 3 steps. The only difference is that when we're plotting lexica, we will need to upload an additional file. I'll explain more about why that's the case in a minute. First, let's try plotting individual words. We start by uploading what's known as our score file. The score file is a CSV file which contains a list of words, and for each word, a number, which we call its score, that indicates how much that word is associated with each trait or correlation header included in the CSV. Let's open an example word score file to see what it looks like. The important thing to note here is that each word has its own row and that each trait is a column, with the scores for how correlated each word is underneath. After we select our score file, the second step is choosing the type of language feature we're plotting. In this instance, we'll select words. Step 3 asks us to confirm our correlation headers. Every column in the CSV we upload will automatically appear here as a correlation header, so here we want to uncheck any boxes that do not correspond to traits we're interested in plotting. If we want to rename the columns for any reason, for instance, modifying OPE to fully spell out openness, we can do that by clicking Rename, which appears as an option to the right of the box. With that, we've completed step 3, and we're ready to generate our plot. One more thing though. We don't need to worry about advanced features for this example, but in case you're curious, selecting advanced features gives you the option to limit how many results are displayed. This can be helpful if you're working with a huge data file with millions of rows. Alright, time to plot. Except, since we've already explored what sample output look like, let's shift gears now and go through the 3-step process using lexica as our language feature. First though, let's talk more about what lexica are, lexica being plural for lexicon. For the purposes of this tutorial, it is enough to know that lexica, broadly defined, are dictionaries containing individual words, and topics, which are clusters of semantically related words, are a specific type of lexicon, and particularly well suited for this plotting tool. We can think of each topic as a category that contains individual words. The topics we'll be plotting in this example were derived using latent Dirichlet allocation over roughly 14 million Facebook status updates from the My Personality dataset. Latent Dirichlet allocation, also called LDA, is a statistical method used to create weighted topics, meaning that each word within the topic has a weight which signifies how important it is to that topic. For example, let's say that we have a topic that we'll call outer space. In this topic, the words star, planet, galaxy, and spaceship would have high weights. Dust, however, would have a lower weight, because while it's technically part of outer space, it isn't something we associate with outer space as directly. To recap, a topic is a cluster of semantically related words which can be viewed as a category in a lexicon, where each word has its own degree of importance to the topic, a weight. For further discussion on lexica, you can watch our LexHub lexicon tutorial. Now that we've discussed a little bit about what topics are, let's try plotting them using the tool. As I noted earlier, regardless of whether we're plotting words or lexica, we will follow the same 3 steps. The only difference is that when we're plotting lexica, we will need to upload 2 files instead of 1, which we can think of as a supplemental part of Step 2. In Step 1, as we did when plotting words, we upload our score file. As was the case for the word score file, each column is a trait, such as openness. However, this time, the score for each trait pertains to the strength of its association with a topic or collection of words, rather than a single word. As you can see, the words that make up the topics themselves are absent from the score file and will be included in the other file we upload. You'll notice that the leftmost column is called TID. This stands for Topic ID. Although it's not required to have a Topic ID column, it can be useful since it allows us to match the rows up to double-check whether the first row of this score file matches the first row of the other file we'll be uploading in the next step. After we select our score file, in Step 2, we'll again be asked to choose the type of language feature we're plotting. This time, we'll select lexica, and we'll be prompted to upload our lexica file. Let's take a look at what a sample lexica file looks like, also called a terms and weights file, since in this example, our lexica are weighted topics. On the far left, we have our topic ID column, and then each column next to that will contain a term that's included in the topic. A weight can also be included next to the term when we're working with weighted lexica, which we are in this example, in which case the columns would alternate between term, weight, etc. We want to make sure that the column headers indicate whether they contain a term or a weight. After we select our lexica file, we're ready to move on to Step 3, which consists of confirming the correlations headers. We'll do the same thing we did when plotting words in the earlier example, making sure to uncheck any boxes that don't correspond with traits we want to plot, and renaming any files if needed. Once we do this, then we're ready to plot. Let's quickly take a look at the output, since the output here will look different than it did when we plotted words. Each dot on the plot represents a topic. When we rest the cursor over a dot, the group of words in that topic appear. Size in the word cloud indicates the importance of that word to the topic, since we're using weighted topics. With that, we have reached the end of the Language Coordinator tutorial. Thanks for watching, and happy plotting.